all of you. Good evening, all of you. So hope you people can hear me. Yes. Good evening. Regarding the yesterday's record, yes, actually I didn't upload it. I was a little busy yesterday. Not only your batch, but I didn't upload any batch record yesterday. I couldn't do that. So I'm going to upload it after the class today. Okay. And don't worry. So there is no continuation of yesterday's class today. So we will be talking about XML processing APIs. Okay. Yeah. Fine. So today the aim of this session is to make you people understand how to process XML data using JAXP API first of all. Okay, JAXP API. JAXP stands for Java API for XML processing. Please make sure that all of you please mute your mics. Okay. So generally you will find that we have two different parsers which we can use here in this API. One is DOM parser, the other one is SAX parser. Yes. DOM, it stands for Document Object Model, and SAX stands for Simple API for XML processing. Yeah. Now, first of all, we'll start with DOM. Let's see what is this DOM API and DOM parser we have here. See DOM parser. Let's try to understand what is this DOM parser. Just a minute. You know, we have something called as a DOM parser. I can say when we talk about DOM parser here, DOM parser reads an XML document and constructs a DOM, that means DOM tree I can say, which represents that XML document. Okay. DOM parser's responsibility is to read an XML document and construct a DOM tree. Which represents that XML document. Yeah. What is this DOM actually? That you need to know. DOM, basically it's a tree, document object tree I can say. Uh, you see, this is a statement I want you people to make a note of. XML DOM represents an XML document as a tree structure. That means the DOM which is constructed by the DOM parser is actually a tree structure. Okay, that XML document is presented as a tree, DOM tree. You know, you'll find that uh, the XML DOM, you'll find that here entire document you have these points which I want you people to make a note of. So it will be difficult for you people from where to start reading or what to read. So these points will help you people. According to DOM, everything in XML is a node. Okay, yes. Each and every XML element which you see is actually a node. And it is represented as a node here in the DOM tree. Each and every XML element will be represented as a node here in the DOM tree. These are the important points. If you know this, then I can say that working with a DOM, okay, will be very easy. Yes. You see, in the DOM tree, I can say that the entire document is a document node every XML element is an element node. You know, the text in the XML elements are text nodes. Every attribute is an attribute node. Comments are comment nodes. Yes. Okay. So this way you'll find that here we have different types of nodes. Yes. Okay. Yeah. Okay. So you'll find that the DOM tree, I can say that it's a complex data structure. It's a tree data structure, I can say. DOM tree. It's a tree data structure where every element, attribute, text content of an XML document, it is represented as nodes. They're represented as nodes here. Yes. Okay. Yes. Every element is represented as nodes. Yes. Okay. Yes. Yes. Let me show you people how this DOM tree looks like. You see, for example, let's say you have this XML data. Let's say you have this XML data. Okay. If you have this XML data, what is it? Just read this XML data once. All of you just go through this XML data. You see, the bookstore element is the root element, and we have book elements here. Each book element holds set of book details. Each book element holds set of book details. So we have several book elements here. Each book element, it holds the details about a book, a particular book, I can say. It holds the details of a particular book. Yeah. Now, I want to parse this XML document. What to do? Let's see. And people who have just joined, you see, I'm talking about JAXP API, which is used to process XML data. And here we are talking about DOM parser, which we use to process this XML data. Okay, so you missed this point, but don't worry now. Again, I'm going to explain this pragmatically. You can make a note of it again later. I'll be with you. So using the DOM parser, now I would like to use DOM parser here to process this XML data. So what to do? So first of all, here we need to parse this XML document to a DOM parser. DOM parser will take this XML document and it constructs a tree like this. You see here, it's not complete tree here with all the elements which you see in that XML document. Only one book element, I guess, it is represented here. Yes. You see, in this tree data structure, you'll find that you got that square, uh, sorry, you got rectangular box, right? Each rectangular box, it represents a node. We call them as nodes. And you know, here you'll find that each for each and every XML element, not only for XML elements, for attributes also, you'll find that node objects are created here. For example, for bookstore, you see a node object is created. I can say that angular, that square, that rectangular box here, it represents that node. It represents that node. I can say. Okay. So bookstore is a root element, right? That's the reason why here it is at the root of the hierarchy. Now, under the bookstore, we got book element, which is a sub element of bookstore. For this book element, again, the book node will be created. Sorry, a node object will be created, I can say. You see, book node. And you see, in the book node, book element, in the book element, we got a attribute category. There is an attribute called as category. For that category, again, an object is created, a node object is created. Again, you see, under the book element, we got elements, sub elements. Again, I can say, like a title, author, year, price, and for title, again, you got an attribute called as lang. You see, title, author, year, price. For every sub element of book, again, you got node objects which are created here. And you see, there is a parent-child relationship between these nodes. You see, at the root of this hierarchy, you got bookstore node object, which is actually considered as a root element. And you see under the bookstore we have child notes. So that book node is the child node of bookstore. It's a child node of bookstore. Yes. Again for the book node also we have child nodes. Like you see title, author, year, price. They are child nodes of book. Again for this child nodes are also you have child nodes. Yes. You see even for the data, even for that data or text content which you got here in that XML document, you'll find that node objects are created here. You see the nodes which you have at the bottom down, completely down, you see we have the node objects. Okay, yeah. So here these nodes, they are again classified. They are different types of nodes based on the element or what exactly it represents. That node object, you see each node object here, uh, either it represents an attribute or an element or a text content, right? Based on that, again the nodes are classified. You see the first node on top, extreme, on top of the hierarchy, bookstore, it's a root element. We say that node is of type root element. You see this is the first element, right? Yeah, which is at the root of the hierarchy. It's a root element. You see book, title, author, year, price, they're all normal nodes, I can say. Yes. Okay. Yeah. You see, these are all elements, element nodes, I can say. Just element nodes. You see, book is an element. On top, it is tagged. Each node is tagged here. If you can see this, it's an element node. The title is also element node. Author is also element node. Year is also element node. Price is element node. When you see this category, it's an attribute of book element. So it is an attribute node. Okay. And you see for title again, you got an attribute called as lang. So it's an attribute node. And down you see the text content also. The text content is also represented using node objects, right? Yes. So that nodes are text nodes. That nodes are text nodes. Yes. This way you'll find that everything in the XML element is represented as nodes here, and they are different types based on the based on what it is basically in the XML document. Yes. Now, why do we need this DOM? Let's see. Uh, just a minute. Yes. So basically, here the DOM tree, which is constructed by the parser, can be accessed using the DOM API, and we can read the data related to that XML through that DOM tree, I can say. It would be rather easy for us to work with this DOM tree instead of directly processing that XML data, I can say. Yes. So what it says the last point here? The DOM defines the objects and properties of all document elements. And you'll find that, you see, in the sense, we'll have objects here in the DOM, right? And properties of all document elements. That means document here means we are referring to XML document. Okay, if you want, I'll use the term XML document. And the methods to access them. You'll find that here DOM provides, you have DOM API, which we can use to access that DOM tree. Not only that, the data which you have related to that XML document, you can access it easily through the DOM API, and you can work with that XML data. Okay, yes. So basically, in simple terms, I can say that DOM parser is constructing the DOM tree, you know, uh, which helps us to easily access that XML data through the DOM tree and process it. That's it. Okay. Yes. So now the question is how to construct this DOM tree and read the data or access the data from the DOM tree. Let's see. So now we are going to write the code. Okay. Having understood the basics of DOM, let's see. Just a minute. Let this ID load. Yeah. So first of all, I'll create a Java project here. Yes. So you can use this JAXP API anywhere in any project, not only simple Java project. And you can use it in web applications or whatever it is. Okay. Yes. Let's say XML processing. We don't need any additional libraries here. Okay, yes. Now, first of all, I need that XML data. Okay, just added it here. I'll copy this XML data. I'll create an XML document here. Let's do that. Books.xml. Okay, yeah. So now we have this XML document with this XML data. Okay. Now what I want to do is here, I would like to read that data, especially that book details, which you got here in that XML document. Okay. Yes. So what to do? We are going to use DOM parser for this. Okay. So let me define a class here. Okay. So you see, first of all, what I'm going to do is we have to create that DOM parser object. We need to obtain the DOM parser object. So if you want to use that DOM parser, you need that object, right? In Java, everything is represented as an object. Even the parser is an object here. Yes. So this is how you'll obtain DOM parser object. You need to create a document builder factory object. Yes, you see, using the to build document builder factory object, we'll create a document builder object. Throws a checked exception. So what is this document builder object? This document builder object itself is a DOM parser, I can say. It's a DOM parser object. Okay. Document builder is nothing but a DOM parser here. Okay, yes. You see, in order to create this document builder object, which represents a DOM parser, we need document builder first. Document builder factory first, I'm sorry. We need document builder factory object first. Okay, yes. So once you got this document builder, which is a DOM parser, now we can ask this parser to parse that XML document. How? By calling this parse method, and you pass that file name. That XML file name, you have to pass it here by creating a file object. What is it? I guess it's books XML dot books.xml. That's it. So this way you need to create a we need to call the parse method of the document builder to ask the parser document parser DOM parser to parse a document, and you'll pass a document XML document which you want to parse. Yes. Okay. So this parse method, now what it does, it will parse the XML document. As a result of parsing, what you're going to get? Yes, let me see what you understood. So when this DOM parser parses that XML document, so what it does basically, it creates a DOM tree. That's right. It creates a DOM tree. Yes. So you're going to get a DOM tree here. Okay. Yes. So, and you see, you'll find that this parse method returns a document object which represents the DOM tree. You'll get a document object here. The parse method returns a document object which represents a DOM tree. Okay. So that whole DOM tree which is constructed now, it is simply represented by this DOM tree, I can say. It is simply represented by this DOM tree. Yes. Fine. A document object, I'm sorry. The DOM tree is represented by this document object now. Now, In this document object, basically now we can use it to access the DOM tree. We got an API completely for this. We got methods which we can use to access the node objects in the DOM tree and read the data. Okay. So now first thing what we'll do is here, I'll use this method. Sorry. Document dot get uh, document element. You know what? You're going to get a node object here. You'll get that root node. You're going to get the root node object here. Yes. Okay. You'll be getting that root node object here. So let me display the name of that node. Now this node object, it represents which element? Okay, this node object here, it represents which element, XML element. Let's see. So here it represents that root node. Then that root node is bookstore, right? Let's see. So we got bookstore here. So that node object. So once you see you got that document object which represents the complete DOM tree. Now you can use it to access the root element. So how will you access the root element? Yes, using get document element method. This method is used to access the root node. Okay. Okay. Here now I would like to access that child nodes here of that bookstore. So how many child nodes do we have for that bookstore? Can you people tell me? How many child nodes do we have here for the bookstore? Direct child nodes, I can say. Only one. Okay, once again, look at this document and tell me. Four. Yes, you got four, not three. Four. Yes, four. That's right. You see, here each book element it is a child node. child element of that bookstore. So let's read this child nodes of that root node. Okay, so now this node object here, it is a root node, right? Yes, root node. Let's say. Now how do we read the child nodes of that a particular node? How do we read the child nodes? You see, you got this method called as get child nodes. Okay, if you want to read the child nodes of any node, then use this method get child nodes. Okay, yes. Yeah. So now this method get child nodes, it returns node list. It returns a node list. What it does, it returns a node list. Yes. So what is this node list? You know, this node list, you can think of it as um, a list object. Okay, you can think of it as a list object, which has got a collection of nodes in it. This node list is a collection of node objects, where each node object represents, where each node object, it represents one child node of that bookstore. Yes, it represents one child node of bookstore here. That's it. Okay, yeah, fine. So now how do we read that node objects from that node list? Node list is a collection of node objects. Please make a note of it if you want. Node list is nothing but it's a collection of node objects. Now let me show you people how to read that node objects from that nodes list. Node list dot, you got length method which returns the size of that node list. Okay, and you see, for each iteration we'll try to read one node object, and to read the node object from that node list, you got this item method, item and pass that index. So you know the index value starts with 0. Okay, each node object in that node list is stored at an index, at a particular index, I can say. Okay, yes, fine. So you're going to create a node object. Okay, that item method, what it does, it returns a node object. Yes. So now we have to check whether that node object which you got is a element node or not. All the book nodes are element nodes, right? Node dot get node type, we have a method, and check whether it is a element node or not. You can check whether it is an element node or not. Yes. and if it is an element node, then I'll read the node name. Yes, I'll call this method node name. Just a minute. Okay, sorry. You see, this way now we can read the child nodes of a particular node here. No, not possible. So we got four nodes here, node names. You see, you got four, right? So you got it here, four. Okay. Now you see, under the bookstore again you got under the book elements again we got sub elements, right? How many sub elements you got here? Again you got four. Actually it may be four. In this case it is four, but I can't say it is four for all the book elements, because you see, for example, you see for this book element, how many child nodes we have here, how many sub elements we have. Eight. Yes, 1 2 3 4 5 6 7 8. So you see, the, you got 8. So it depends, but it doesn't matter for us. Now we can read them. Now I would like to read the child nodes of book node. I would like to read the child nodes of book node. So let's try to do that. See, here you're getting a book node, right? For each iteration you'll be getting a book node. Okay. Now, how do I read the child nodes of book node here? Can you people tell me? How do I read the child nodes of book node? Book node dot get child nodes. Very good. Yes, that's right. You see, book node dot get child nodes. Again, what this method returns here, get child nodes method, what it returns? Yes, it returns a node list in which you'll have the list of node objects, okay, which you have under that particular book node. Yes. Yep. Node list. Okay. So I can say this is a book node child list. Okay. Again, now we have to read the elements. So I'll use for loop. So to find out the length, I'll call this method called as book node child list dot get length. And you see here, what I'll do is I'll check this condition. So why we need to check this condition always? What do you people think? Why I'm checking for this condition here? Why I'm checking whether the sorry, just a minute. Why I'm checking for this condition? Yes. So you'll find that uh, that that elements basically of child elements. Basically, I can say that sometimes even the start and end elements will be considered as child nodes. Okay, so we want to make sure that always they are this start nodes itself. Okay, yeah. So and we would like to only consider this element nodes, not attribute nodes. I'm sorry. Especially, we would like to only consider this attribute node. Sorry, element nodes, not attribute nodes. For example, you see here for this book we have this category. So you see that category which you got here, it's not an element node. I don't want to consider this one. It is also treated as a child node now. So we don't want this one. Okay. Yes. Fine. Yeah. So now let's try to print this details. Book node, book child node dot get node name. That's it. Okay. Yes. Okay. Yes. So now we'll get the child nodes of that book node. So let me run this code. Okay. Sorry, just a minute. There is some issue. Oh, sorry. I have to use J here. J. The inner loop is J. Yes, you can check this once. In the first line, you got that book element, and now under the book element, you have the child node details. Okay. Now you see, again, the child nodes of book nodes, each child node of book node, in turn, it holds the data, right? In turn, it actually holds the data, right? The text content. You see it here. You see, title has got a text node. That is the text content. Okay. Yes. Now, the child node, another child node, we have that particular text content. See, the text content is represented by this particular um, text node objects here, right? Yes. You see, there is exactly one child node for all the child nodes of that node objects, book child node objects, right? You see, for each book child node objects, there is exactly one child node, just one child node. That's it. Okay, exactly one child node is there. Yes. Okay. Yes. So now, can you people tell me how do I read that child nodes of that book child node, child nodes, book child nodes, child node here? Yes. Yes. What to do? Okay, it's very easy. So now you see here, what I can do is I'll use this book node child object reference and I'll call that get child node. Or actually, we have a method get first child. First child. This is useful. You see, you have only one child node, right? We have only one child node because we got only one child node. What I will do is here I'm going to use this method called as first child node. So the name itself indicates it returns the first child node of that particular node. There is only one child node, right? So the child node objects will be written here. The child node object will be written. That's it. Okay, yes. So you're going to get a node object. I'll take that node object. Again, I'll check here, or we don't need to check this time because there is only one node. So I would like to read the data. So node dot get text content. So whatever the content you have, whatever the content you have, you see, we'll try to read it. Okay, yes, fine. Now you can check this once. You see, book title. What is the title value? Everyday Italian. Author. Okay, we got an author here. I can't spell it. Year 2005. Price 30. Again, another book title. Harry Potter. Author. Okay, J.K. Rowling. Year 2005. Price $29.99. You see, we are done reading the data from the XML document here. Yes. So hope you people got it, right? So anyone got any questions or issues in this regard? Okay, good. Now I have a question for you people. All of you listen to me carefully. Now you see, whatever the data we have here, what if we are supposed to represent this data appropriately in Java? The bookstore data, whatever we have in that XML document, if you were to represent this XML data in Java, so what you will do? How will you represent it exactly? Can you people tell me? Yes. In the form of objects, that's right. Now, can you people give me the class definitions, at least a very high level overview of that class definitions? Okay, for this particular bookstore XML document. Yes. Okay. Title. Yeah. Yeah, you see, you'll find that you'll define a class called as book, and in that book class we'll have these fields like title, author, year, price, even that attribute also will be declared as a field itself. Yes. Class book where you'll have these fields title, author, whatever the sub elements you have, you'll represent them as variables or fields here. And then what else? That's it. Do we need any other class here? That's it. We need one more class. Class called as bookstore. Sorry. Class called as bookstore. And here you'll have list of book objects. So bookstore is a collection of books, right? So that is how you're going to represent that XML data here, yes, in Java. So we'll have a bookstore object, and in the bookstore object you'll have list of books or collection of books. Yeah. So I have a task for you people. Now you see this code which you got here, that code which I've written. I'm just trying to read that XML data. I'm printing it. We're just printing that XML data which you're fetching, right? So instead of printing that XML data, whatever the data we have here in that XML document, we are simply printing it after reading it. Instead of printing it this way, that data, I would like to store it into Java objects appropriately. I would like to store it into Java objects appropriately. Yes. Okay. Yes. So will you people try that? Now you know the class definitions for that, how that XML data is represented here. The only thing is you need to create appropriate Java objects and store the data into the Java objects. Yes. Will you people try that? Can I have yes or no? Okay. Yes. Good. So now you see this is how you'll use a DOM parser. Okay. So you see that a DOM tree, to traverse through that DOM tree or to iterate through that DOM tree, you'll find that we got the methods. We got the methods here appropriately. Yes. Now you know what, but you will find that there is a drawback or limitation for this DOM. So can you people tell me what is the drawback or limitation of this DOM? Yes, tell me. Others can think about this question. Yeah. Yes. What's your question, Saurav? Now you see structure. If you read that XML document, of course you'll know it, right? You should have, yes, knowledge of that XML document which you're parsing it, definitely, where you'll have all the details, right? So when you look at that XML document, you'll come to know how that structure will be created, right? Yes, which element will be sub element of which element. So all such details you can get it from that XML document itself. Yeah. So in the beginning, that is what I've explained. So how that a DOM tree will be created. You got it? So any other questions? You see, yes, it is possible. It is also possible because the code which I've written here, see, I didn't specify any details particularly like, the size of that list or something like that. Yes, you can use that code, definitely. The code exactly which we have written here, even though you don't know that XML document still actually, but only the last thing which I've got here, you see, I can say that at this point here itself, this is very specific to this XML document, reading the child nodes. Yes, you see, we know that for that particular book child node, there's only one child node, so I'm calling that first child node method. Otherwise, if you don't know, again you have to call that get child nodes itself to fetch the child nodes list if you don't know. So this one, this code I can say here, and that line, it is very much specific to this XML document. We can write generic code, yeah, it's possible. Yeah. Okay, so any other questions? Yes. Any other questions? Okay, good. So I have a question for you people now. You know what? I can say that there is one limitation or drawback for this particular DOM parser. So what is the drawback or limitation of this DOM parser? Yes. Yes, that's right. So I got one of the answers. Wastage of memory as it stores complete XML file. So how it is storing the complete XML file here? Yes. You see, especially I can say that the node objects which are created, you'll find that, see, for each or for everything in XML document, you'll find that node objects are created, right? For everything in XML document, you'll find that node objects are created. Yes, right? For attributes, for root, for elements, you see, for text content, for everything, for almost everything, node objects are created here. So you see that creation of that document tree or DOM tree is complicated, I can say. Creation of that DOM tree or document tree is complicated, I can say. Okay, yes. Got it. So first of all, you see the DOM parser has to read that XML document and construct a DOM tree. Again, creating that DOM tree is also complicated. It's a complex data structure, I can say, where a lot of node objects are created. You'll find that a lot of node objects are created. And later on again, you see, reading the data from that DOM is also little complicated here. Why? Because you see, you have to traverse through this nodes and all and read the data, right? You need to traverse through each and every node and read the data, right? Yes. So this is another thing which you need to consider here. Okay. Yeah, sorry guys. Sorry to make you people wait. So, hope you're able to hear me, right? Yeah. So we are talking about the limitations of this DOM. So every time you see to parse to read that XML data, first of all, like we have to construct that DOM tree. That not we in the sense the parser has to do that. And you see, as the number of elements, attributes are more, the number of node objects which has to be created also will increase, right? So which is a limitation basically. Which is a limitation basically. Okay. Yes. So you know what here you will find that to overcome this limitation, you know, we use another parser. We use another parser. What is that parser? Sax parser. Okay. So in DOM parser, we have the overhead of creating that DOM tree. Simply, I can say that we have a overhead of constructing the DOM tree in the Sax parser. Okay. Yes. Sax parser. So we can overcome this limitation with, sorry, in DOM parser we have that limitation. Now we can overcome that limitation here using the Sax parser. So if you use Sax parser, you'll find that we don't have a overhead of constructing the DOM tree or node objects. We don't have an overhead of constructing the DOM tree. Okay. Yes. So Sax parser actually it is event based. Event based. So no additional objects will be created here. You will find that additional objects are not created when it comes to Sax parser. Okay. So that drawback you see is addressed here in Sax parser. It's event based parser, I can say. You know, this Sax parser what it does, so it is based on events. So whenever the parser, you know, it comes across Sax parser, if it comes across an element, you know what it does is here it will um, it won't create any node object or something like that. It will read that XML details and it will pass it to the listeners. You'll have something called as, you know, listener. So that listener will be using that details, that element details, and it can read the data. Okay, you'll have that. You'll find that in Sax parser, listener plays a key role. So whenever you know the listener, sorry, that parser comes across a element, all the details about that element will be passed on to the listener. So listener can take these details and it uses it to read that element details here. Okay, yes. So this is what happens. You'll find that you'll have a listener which will simply read that element details. So that parser will pass the element details, which will be used by the listener, and it will process the data accordingly. That is how the listeners work. That's it. Yes. So going forward, you'll find that this SAGs or DOM parsers, you see, you'll find that we have to explicitly process the data and all such things, right? So we can overcome this, uh, you know, redundant code, writing this code to read each and every element and all. Okay, what you can do is basically you'll find that we can create sorry, we can use JAX-B, where we don't need to write the code explicitly, okay, to parse the XML document. So you have another API, so which can help us to easily process that XML data without need for parsing it explicitly. Okay, we'll see that. Fine. So, but we'll talk about, or we'll work with this parser in the next class. And after I'm done with this parser, in the next class itself, I'm going to introduce you people to JAX-P. Yes, I need just 40 minutes or so to talk about SAX parser. I need I need only 40 minutes or so to talk about the SAX parser. After that, I'll start with JAX-P. Okay. Yes. Fine. So once we are done with JAX-B, so we'll start with web services. Okay then. I'll stop it here today. Okay, let's meet tomorrow and talk about SAX parser and followed by JAX-P API. Yes, which is an advanced API for processing XML data, I can say. Yeah, thank you all.